Okay, so this is just an extra examples that aren't really in your notes. Students tend to struggle with solving linear inequalities graphically, but graphically is great because it allows you to sort of understand what's going on. So I'm going to do a couple more examples graphical. So again, like I said, this is extra. This isn't in your notes. This is sort of just extra examples. The first one is going to be, I'm going to give you a graph, all right? So if we're given the graphs of f of x and g of x, which I'll graph here in a second, we know they intersect at 8, 7. Alright. A, when does f of x equal g of x? B, when does f of x, or when is, not does, when is f of x greater than g of x? And when is f of x less than or equal to g of x? And we're going to do this graphically. Alright, so I'm going to graph the pictures. So here's my y-axis. Here's my x-axis. They meet at 8, 7, so I'm just going to mark off 8, 7. So this is where they meet. Alright, so suppose g of x is this blue line, so there's g of x. And then f of x is this red line. Alright, so g of x is the blue line, f of x is the red line. They meet at the point 8, 7. Make sure that was the point they were supposed to meet at. Yes, 8, 7. Alright, so the first question is, looking at the graph, when do they intersect? When is f of x equal to g of x? Well, that's this moment. Now, when is it? It's the x value. It's always, the answer to the question is when is it, is always at what x value are they the same? And so f of x equals g of x when x is 8. They both equal 7. All right. At 8, both of them are equal to the y value 7. And so the answer to A is x equals 8. That's the answer. They're equivalent at 8. Right, so the second question, B, when is f of x bigger than g of x? Alright, so when is it bigger? F of x is bigger than g of x. And so I want the function, the red function, to be bigger than the blue function. And so remember, bigger, f of x is above g of x is what we're looking for, right? Bigger. And so it's this region, right? This region here is when f of x is above g of x, right? It's bigger than g of x. F is greater than g. Starting at this moment, 8, when x equals 8. And then continuing on indefinitely, right? It's shooting off indefinitely, so forever, from 8 to forever, f of x is the bigger function. And so the answer to B is from 8 to infinity. Not including 8 because it's not equal to, so it's parentheses, not including 8. Alright, so the answer to B is 8 to infinity. Alright, then the last question. I'm going to erase what I've drawn here because I'm going to redo stuff. Alright, so C is when is f of x less than or equal, so they're equal to, so I'm allowed to have 8, right, that's when they're equal to. Less than, so I want f of x to be less than g of x. Well, I want when f of x is equal to g of x and when f of x is below g of x, right? Both of those things need to be true. And so when does that occur? Well, they're equal at that moment. And then f of x is below g of x, right? It's below the blue function here. All right, going all the way back. And so that means starting at this moment 8 and going on for forever in the infinity direction, my f of x, the red function, is less than or equal to the blue function. And so the answer for that one is negative infinity to 8. And this time I include 8 because of the equal to, right? The equal to allows me, I want every place where the red function is the same as, well, there's only one place where it's the same as 8, and smaller than it. Well, it's smaller than it. When it's below it from 8 to infinity. All right, so that's an example of if you're given a graph. All right, the second example we're going to solve graphically again, but this time we're going to do it on the calculator. All right, so solving this graphically. So I'm going to give myself a little more room. Oops. Alright, I'll just erase what I have instead of trying to do that. Okay, so the second example is we want to solve graphically when the square root of 2 times x is greater than or equal to 10.5 minus 13.7x. Alright, I'm going to solve this graphically. So to solve that graphically, in y1, I'm going to graph the function square root of 2 times that. Make sure you know it's the square root of 2 number, separate, we multiply by just x. And then in y2, I'm going to let be the 10.5 minus 13.7x. So I'm going to go to my calculator, clear out what I have in here, so clear that out. In y1, it's going to be the square root of 2. Alright, then I'm going to hit over, so I'm not under the square root of 2 anymore, times x, because x is outside of the root. And then the second function was 10.5, so 10.5, minus 13.7 x, and if I want to look at my table to see where the window is, so it looks like, alright, so it looks like my 0 should land between 1 and 0. Alright, somewhere between 1 and 0 should be my 0, and so a standard window should work just fine, right? Because at 1, my y value is negative 3.5. At 0, my y value is a positive 10.5. And so between those two, I've got to hit 0. Alright, so I know it's going to happen between 0 and 1. Alright, so a standard window should work, so let's make sure my window is standard. It is. Alright, graph it. And so there it is. And so there's my two functions. The first function was the root 2x. The second function was the 10.5 minus 13.7x. Alright, so first thing I want to find is where do they intersect. So remember, second trace, 5, first curve, second curve, gas. So I'll make sure I get as close as I can at that moment. Enter, first curve, second curve, and gas. Alright, so it looks like it happens at 0.6947. And so now I'm going to go back and just kind of plot the points on my, so again, plotting it. So there's my x-axis, there's my y-axis. And so they meet really close to the origin here at the x value 0.694. Alright, the first function, actually almost cuts right through that. I'm going to erase that. My first function should go through the origin, but there's the square root of 2x, which is my y1, and then the second function, that's the y2, which is the 10.5 minus 13.7x. Alright, they met at this moment, which I just erased. Alright, they met at that x value, which was 0.694. Alright, that's where they are equal. Alright, that's their point where they intersect, that's where they're equal. Alright, so the question was asking, so now that I've got the graph, when was the square root of 2 function, which is this one, alright, so that's the square root of 2 function, bigger than the other function? So again, this would be the other function. Alright, so there's my green line, and there's my yellow line. So I want my yellow line to be bigger than my green line. Well, when is the yellow line above the green line? It's above the green line from this x value to infinity, right? It's bigger here. This is when it's bigger. And so the answer is 0.694 to infinity. Alright, so again, the answer is 0.694 to infinity, and then I can't remember if it's an equal to. It is an equal to, so I include the 0. Not the 0 in this case. I include where they're equal, which is 0.694. Alright, so the answer, the function, the square root of 2x, is bigger than the 10.5 minus 13.7, or equal to the 10.5 3.7, between that decimal, 0.694, to infinity. If I pick any number between that decimal and infinity, the square root times x will be the larger function. Alright, and so that's the answer to that one. Alright, so again, this is just a couple more graphical examples because I didn't do very many, and graphical examples typically are hard, so just a couple of extras. Alright, again, for your information, I guess, if you want to look at those. Alright, we'll stop there, and then we'll get into 2.4 in the next one.